Tornadoes are among the most fascinating and terrifying natural phenomena on our planet. These powerful, swirling columns of air extend from a thunderstorm to the ground, capable of causing immense destruction in their path. Often referred to as twisters or cyclones, tornadoes are characterized by their funnel-shaped appearance and their ability to generate wind speeds that can exceed 300 miles per hour, 480 kilometers per hour in the most extreme cases. To truly understand tornadoes, we must first delve into their basic structure and formation. At its core, a tornado is a rapidly rotating column of air that is in contact with both the surface of the Earth and a cumulonimbus cloud. This connection to both the ground and the storm cloud above is crucial for the tornado's existence and power. Tornadoes typically form under specific atmospheric conditions, most commonly in what meteorologists call supercell thunderstorms. These are particularly large and severe thunderstorms characterized by a rotating updraft called a mesocyclone. While not all supercells produce tornadoes, they provide the ideal environment for tornado formation. The process begins when warm, moist air near the ground rises rapidly into the atmosphere. As this air ascends, it cools and condenses, forming the thunderstorm cloud. If conditions are right, this rising air begins to rotate, creating the mesocyclone. The rotation is often initiated by changes in wind speed and direction with height, a phenomenon known as wind shear. As the rotating updraft intensifies, it can create an area of low pressure near the ground. This low-pressure zone pulls more warm air upward, further fueling the storm's rotation. If this rotation becomes tight enough and extends from the cloud base to the ground, a tornado is born. It's important to note that while this is the most common method of tornado formation, tornadoes can also form in other ways. For example, some tornadoes can develop from a rotating wall cloud, a lowering of the rain-free base of a thunderstorm, without the presence of a supercell. A typical tornado consists of several key components. 1. The funnel cloud. This is the most recognizable part of a tornado, the visible condensation funnel made up of water droplets, dust, and debris. It extends downward from the base of the thunderstorm. 2. The vortex. This is the actual rotating column of air, which may be wider than the visible funnel cloud. The strongest winds and most severe damage occur within this vortex. 3. The debris cloud. As a tornado moves across the landscape, it often picks up dust, debris, and objects from the ground. This creates a dark, often wider cloud at the base of the funnel. 4. The inflow jets. These are the strong winds that flow into the tornado at its base, feeding it with more energy and potentially making it stronger. 5. The parent cloud. This is the larger thunderstorm system from which the tornado is typically a cumulonimbus cloud in a supercell thunderstorm. Not all tornadoes are created equal. Their intensity can vary greatly, from weak twisters that barely cause any damage to monstrous vortexes capable of leveling entire neighborhoods. To categorize tornado intensity, meteorologists use the Enhanced Fujita (EF) scale, which replaced the original Fujita scale in 2007. It's crucial to understand that the EF scale is a damage scale, not a wind speed scale. Tornado intensity is assessed post-event by examining the damage left behind rather than by direct wind speed measurements, which are extremely difficult and dangerous to obtain. While tornadoes can occur in many parts of the world, they are most frequent and intense in a region of the United States known as Tornado Alley. However, the global distribution of tornadoes and their seasonal patterns offer fascinating insights into the atmospheric conditions that foster these powerful storms. Tornado Alley is a nickname for an area in the United States where tornadoes are most frequent. Traditionally, this region includes the states of Texas, Oklahoma, Kansas, Nebraska, and parts of South Dakota, Minnesota, Iowa, Illinois, and Indiana. However, it's important to note that the boundaries of Tornado Alley are not strictly defined and can vary depending on the criteria used. The unique geography of this region creates the perfect conditions for tornado formation. The flat plains allow cold, dry air from Canada to collide with warm, moist air from the Gulf of Mexico. This collision often results in the development of powerful supercell thunderstorms, the breeding grounds for tornadoes. Tornadoes can occur at any time of day, but they are most common in the late afternoon and early evening, typically between 3 p.m. and 9 p.m. local time. This is because tornadoes are often associated with supercell thunderstorms, which tend to be strongest during this time period when the atmosphere has had all day to heat up and become unstable. However, it's crucial to remember that tornadoes can and do occur at night. Nocturnal tornadoes are particularly dangerous because they're harder to spot. People are less likely to hear warnings while asleep, and the storms that produce them may have different characteristics than their daytime counterparts. Understanding these geographical and temporal patterns of tornado occurrence is vital for both scientific research and public safety. In the next section, we'll explore the impacts of tornadoes on human society and the environment, as well as the measures taken to predict and prepare for these powerful storms. Tornadoes are among the most violent atmospheric phenomena on Earth, capable of causing catastrophic damage in a matter of minutes. Their destructive power comes from a combination of extreme wind speeds, flying debris, and the potential to spawn additional hazards such as lightning and flash floods. Tornado disasters serve as stark reminders of the immense power of these natural phenomena and the importance of preparedness and early warning systems. In the next section, we'll explore how meteorologists predict tornadoes and the measures taken to protect communities from their devastating effects. As destructive as tornadoes can be, advancements in meteorology and technology have greatly improved our ability to predict their occurrence and warn people in their path. This section will explore the methods used to forecast tornadoes, the warning systems in place, and essential safety measures for individuals and communities. Despite these tools, tornado prediction remains challenging. While meteorologists can identify conditions favorable for tornado formation, pinpointing exactly where and when a tornado will touch down is still beyond current capabilities. Scientists continue to study tornadoes to improve prediction and safety measures. While tornadoes remain one of nature's most unpredictable and destructive forces, our growing understanding and improved technology continue to enhance our ability to prepare for and respond to these powerful storms.